This video is about vectors. I did this tailored for Dr. T's class. So a vector is a quantity that has magnitude and direction. And when you're saying magnitude, what you're saying is this vector right here, this magnitude represents a length. So the length is always going to be positive. The direction, you can, let's say this is the vector, you draw it from the x-axis here, you can always measure the angle of the vector, and that's going to be the direction that the vector goes in. For this class, we also like to refer to our x-axis as the I component of the vector and the y-axis as the j component of the vector. So for example, this vector is at the point 0, 0 and it goes to 3, 2. So what you would say is that's 3i, 2j. You always want to measure the vector also from the positive x-coordinate. And what that's going to do is when you're measuring the vector, no matter where it is, as long as you're measuring it starting from the x-axis and going to wherever the vector is, you're always going to get the correct sign for your x and y components, or your i's and j components. For the vectors, you always want to do it in a way so that the head meets the tail of the next vector, and that's how you're going to be able to find angles between vectors. Don't do it like this. This is not correct, so do it this way, okay? So for the distance and magnitude, to solve for distance and magnitude of a vector, you're going to use this formula, and this formula looks familiar to you, right? This is kind of like the Pythagorean theorem, just rewritten differently for vectors. So I here is like your x component and j is like your y component. So in a way, it's kind of like a squared plus b squared equals c squared here, right? And you're finding your i's and j's of a vector. So every vector that you see here, there's always an x and a y component. And to find the x and y component, you're going to use this formulas right here. And like I showed here, you can measure it from wherever the vector is using that x-axis, like this is the negative x-axis. But if you were to do it from the positive x-axis, which is how Dr. T prefers you to do it so you don't confuse yourself, you're always going to get the correct, like this would always come out with a negative x and a positive y, whereas this would just come out with a number, and then you have to go, okay, what quadrant is that in? And that just gets too confusing. Also, when you're working with vectors, you can always find the theta of the vector if you know your x and y's by doing inverse tangent j component over I component, which is similar to y over x. So using that as our basis, this is just the starting material for vectors, just to get your feet wet. But let's do an example here real quick. So I've got this problem here. It says a hiker begins a trip by first walking 25 kilometers southeast from her car. She stops and sets up her tent, then she walks 40 kilometers in a direction 60 degrees north of east, at which point she discovers a forest ranger's tower. So we're talking about two different vectors here. So let's say this is her car, and she's starting right here at 0, 0. She's going to go 25 kilometers southeast, so it's exactly 45-degree angle here. And then once she sets up tent here, she's going to go 40 kilometers in a direction 60 degrees north of east. So if this was the x-axis here, she's going 60 degrees north of east. So here is her 40 kilometers here. So now it's asking what is her resultant vector. So you're looking at two vectors here, and you're trying to find the resultant vector. How far is she from her car? So now she's here. How far is that point from her initial starting point here? And what is the direction of the resultant vector? They want to know what angle is this from the x-axis. So you're going to find with vectors that you always want to break the vectors down into the I and j components. And we showed you that earlier with this equation right here, or these two equations. And this is going to solve for your I, and this is going to solve for your j. So, for example, let's take the vector A right here, break it down and say, okay, 25 kilometers for this vector. So you say 25 cosine 315. Now we can do a negative 45 and we'll find the same thing, but we always want to do the angle starting from the positive x-axis. So we're going to go counterclockwise all the way around. You find the vector here, and that's going to result in a 315-degree angle. So you say 25 cosine 315, you get 17.7 for the I component, that's how far it's going in the x-axis, and 25 sine 315, you get negative 17j. So that's going negative y-axis, which is your negative j component here. You do the same thing for vector b, so you get a different quantity for that. And you're saying, okay, well, if I add these two vectors together, if I add my x component for this one, my I component, and I add my I component for this vector, my resultant vector should span the same distance as both of these vectors in the I and j components, which means in the x and y axis, right? So, and that's what you see here. Here in the y-axis, it's going down this much for vector A. It's going all the way up this much for vector B. So when you add those two, your resultant vector is only going to go up this much right here. Now, that's what you do. You just break it up. Here's your i's and j's, and you add those together to get that. And your j's here to get that. And what that means is now the resultant vector is going to go 37.7i, 16.9j. Now, how far is she from her car? So she's here now. How far is she from her car? And all you do is you say, well, here is the new vector. Let's give it a right triangle here. And we can measure it by doing a squared plus b squared equals c squared. Or rewritten in a way for vector is this way. And you just plug your numbers in and you get that this whole thing right here, the distance is going to be 41.3 kilometers. And remember, that's a magnitude, so that's always going to be positive. Lastly, what is the direction of the resultant vector? So now this is the only vector we're looking at. So what's the direction? How far is it from the positive x-axis? And we know that it's going, obviously, it's going in the specific x axis and y axis, so you know your x and y numbers. So all you do is you just plug them in here. So the resultant vector ended up here with i's and j's. You take your i's and j's and you plug it into the inverse tangent, and that's how you find your true theta from the positive x-axis. And that pretty much sums it up for this specific problem. Good luck, guys.